All right, let's jump right into it. Welcome to this explainer. If you've been looking to modernize your factory floor, but maybe you're just not sure exactly where to start, you are absolutely in the right place. Today, we're taking a close look at the true anatomy of an automated cell. And we aren't just looking at isolated random pieces of tech here. We're going to mentally build a vision-guided collaborative robot cell completely from scratch, exploring the eyes, the muscle, and the hands that literally make flexible automation a reality.
Okay, let's dive into this. At the very heart of almost every cobot deployment is an action that seems deceptively simple: pick and place. Whether you're doing CNC machine tending or end-of-line palletizing, this is the absolute workhorse application of collaborative robotics. And honestly, why wouldn't it be? Because this core motion, locating a part, picking it up, and putting it down somewhere else, that accounts for the absolute largest pool of repetitive, ergonomically taxing manual labor in manufacturing today. Automating this single, repetitive motion, that gives you the absolute cleanest ROI math you can find on a factory floor. But this brings us to a really critical question, right? Think about the automation setups you've actually seen out in the wild. What separates a truly flexible factory cell from a fragile one? The kind that constantly breaks down or constantly needs a human to jump in and babysit it? Well, you might be surprised to learn that the secret to high uptime isn't actually the robot arm itself. Nope, it's the intelligence feeding it. So here's our roadmap for putting this cell together. First, we'll look at the pick-and-place problem. 2, giving your cobot eyes. 3, choosing your robotic arm. 4, grippers, the final link. And 5, we'll cover 3 core application patterns. Okay, section 1, the pick-and-place problem. The simple, unavoidable truth is that traditional robots are blind, literally blind. A robotic arm on its own cannot adapt to parts that move, rotate, or stack unpredictably. It's kind of like asking a person to assemble a jigsaw puzzle while completely blindfolded. Everything has to be in the exact, perfect spot. Every single pick has to start from a precisely fixtured position. And getting that precision requires custom nests, mechanical bowl feeders, and insanely tight upstream tolerancing. These older traditional cells, they're fragile. They work flawlessly for high-volume, single-part runs, sure, but they completely fall apart the second you need to change SKUs, handle mixed cases, or heaven forbid, deal with randomly placed parts. And the result? Hours and hours of agonizing changeover time. Which brings us to section 2, giving your cobot eyes. Now, what's really interesting about this slide is how your choice of vision system completely depends on how your parts are actually presented. A 2D system is great. It gives you X and Y coordinates, which is perfect for flat, fixtured parts, but it has zero depth perception. If you step up to a 2.5D system, you get that depth awareness. That means it can handle parts of varying heights or stacked items, as long as they aren't totally jumbled up. But for true random bin picking, where parts are overlapping and sitting at completely arbitrary, odd angles, you absolutely have to use a 3D system to capture that full pose and orientation in 3D space. Naturally, that comes with a higher cost and a slightly longer commissioning time. But honestly, giving your cobot sight has never been more accessible. Take a look at these entry points. The On-Robot Eyes is a 2.5D system that takes literally minutes to commission. You just do a simple one-picture calibration, and it handles sorting in depth. And for a purely 2D application on a universal robot, the Robotics Wrist Camera Kit is essentially plug and play. Getting your object location set up takes maybe 5 minutes, and there's absolutely zero coding required. You are up and running almost instantly. It's a total game changer. All right, section 3, choosing your robotic arm. Universal Robots pretty much dominates the pick-and-place landscape, and their lineup is purpose-built for this exact stuff. Choosing your arm here is strictly driven by 3 things: your payload, your required reach, and your cycle time targets. The UR12E is your classic workhorse for mid-payload tasks. Now, if you need heavy-duty capability but you're constrained to a compact cell, the UR16E is your go-to. For high-speed, cycle-time-driven tasks, the newer UR15 brings an incredible 5 meters per second tool center point speed, meaning it moves insanely fast exactly where you need it to. And for long-reach palletizing or really heavy lifting, the UR20 and UR30 step up with up to 1750 millimeters of reach and a massive 30 kilograms of payload capacity. Next up, section 4, grippers, the final link. So the crucial point is really understanding the physical properties of your part. Because look, there's no use having perfect 3D vision and a super strong arm if you literally can't grip the thing. The main dichotomy in end-of-arm tooling comes down to shape. Vacuum grippers are your default go-to choice for smooth, flat-faced parts, boxes, or sheet stock. But for porous, deformable, or round parts, you have to switch to mechanical parallel or finger grippers. These rely on form closure, which essentially means the mechanical fingers physically wrap around and hug the geometry of the part so it securely locks in and won't slip out. Looking closer at vacuum solutions, the tech has evolved incredibly fast. If you don't have pneumatic airlines easily accessible on your floor, it is no longer a deal breaker. Not at all. Solutions like the robotic e-pick are completely air supply free. They just connect right to the cobot wrist. OnRobot's VGC10 and SMC ZXP E5 are also fantastic electric options that completely bypass the need for external pneumatics. And when you need to lift heavy stuff, Robotics' PowerPick family scales all the way up to a 30-kilogram payload with an array of cups that completely eliminates the need for annoying tool changeovers across different box sizes.
But what about those tricky, oddly shaped items? That's where mechanical solutions shine. The RoboTalk 2F140 gives you an incredible 140mm stroke with adaptive form closure, so it can handle a huge variation in part shapes. Then there's the SMC LEHR series. This one features a self-locking mechanism that engages on power loss, which is brilliant because if your facility suddenly loses power, it won't drop a heavy metal chunk onto your expensive machinery or worse, onto someone's toes. And if you're palletizing and need to handle both standard boxes and slip sheets, the OnRobot 2FGP20 is an electric gripper that literally combines wide-stroke fingers with an integrated vacuum. It's doing the job of two tools in one setup.
Section 5, 3 core application patterns. Let's move to and see how this builds together in the real world. Pattern number 1, conveyor pick and place with drift compensation. Look, this is the single most common cobot pattern you're going to encounter, and I highly recommend it as your lowest risk first deployment. Basically, parts arrive on a conveyor in roughly known positions, but they always have some positional drift or rotational variation. By throwing a 2D or 2.5D vision system on there, the cobot can instantly locate each part, compensate for that drift, and then perfectly pick and place it into a downstream nest or carton. Compensating for drift on the fly is huge because it totally eliminates the need for those restrictive, highly engineered conveyor guide rails. Moving on to pattern number 2, random bin picking. Okay, this is arguably the most demanding scenario in factory automation today. Your parts are arriving totally jumbled up in a chaotic bin. They're overlapping, they're tilted, they're at all different heights. To actually pull this off, you need a true 3D vision system to resolve the complete pose of the part. Plus, you need an adaptive gripper that can sort of plunge down into the bin and extract the part without colliding with any of its neighbors. It is an extremely high-value task that yields massive ROI. But just a heads up, it does require significantly higher engineering effort to perfect all those complex motion paths. And finally, pattern number 3, structured palletizing by part height. This pattern is all about the heavy lifting and highly organized stacking. Finished products are being placed into precise pallet patterns. Here, the vision system acts as part presence verification and does some minor orientation correction. This is where you see all these components orchestrate beautifully. You pair a heavy lifter, like the UR20 or UR30, with a vacuum tool like the robotic power pick. It uses pre-programmed layer patterns and vision-derived offsets to drop parts perfectly at the correct stack height and angle, over and over again. Now, when you're planning out these deployments, we really need to set some realistic expectations around commissioning times. If you're tackling that first pattern, a conveyor pick with a wrist-mounted 2D or 2.5D camera, you are looking at days, maybe a couple of weeks max to get it fully commissioned. It's incredibly plug and play. But if you're going after true 3D random bin picking, you should expect that to take weeks to months. The vision parameters, the motion paths, the gripper geometry, they all interact heavily in 3D space and just require a lot of intensive, real-world tuning against the actual parts. The good news is, you absolutely don't have to figure out all these combinations alone. To help scope out a cell, you can always lean on automation distribution. They're an authorized distributor for literally all the hardware we've talked about today: Universal Robots, Robotic, OnRobot, and SMC. They offer some really deep application support to help you precisely scope the specific arms, eyes, and hands that will actually work on your unique factory floor. So I want to leave you with this one thought as we wrap up our explainer today. Really take a hard look at your own operations. Think about the manual tasks that are constantly holding up your throughput, or the ones causing real ergonomic strain for your team. Which of these 3 vision-guided patterns does your factory need right now to finally eliminate its worst bottlenecks? Because the technology is here, it's highly flexible, and it is entirely ready to transform your ROI. Thanks so much for joining me, and keep learning.